Okay, boleh start.
Okay, Assalamualaikum and good night. My name is Nur Sham. This is my project. What we projects about the SODA can use the quadratic programming optimization method. Next. Okay. This my group. List of the group member. Myself is Nur Sham bin Luqman, Muhammad Asraf bin Azmi, Muhammad Syafiq Hafizi bin Hamzan, Muhammad Firdaus bin Abdul Aziz. Next. Okay. Review of automation techniques. Introduction. The standard shape of the overall automation trouble in the order to be solved through the techniques. This simple method. Next. Okay, introduction. Site as constraint can be solved by the way of direct implement into the algorithm. Most of automation algorithm remember face constraint one by one for the equality and inequality constraint. a good set a rule be no means violates any of the site constraint. Next. Optimization method. Gradient algorithm are extensively used to clear up the most optimization problem in engineering. There are many B2 efficiency can clear up issue with hunger variety and of the level variable and general required little turn of the problem speech parameter. Next. Gradient-based algorithm. A balanced furthest boy on a hill can use gradient-based total automation to reach the top of a hill, in which step 1 is to use the gradient record to find the direct as wish to go. Next. Gradient-based algorithm, finite distinction gradient dominant, the total compilation time is required to be final and automation as a minutes. We design has a get animation to the supply code and automate the definition may be used to achieve the preferred gradient information. Next. The gradient-based algorithm, the automation design point X must be feasible at the optimal design point. The gradient of Langrenus must be vanished. Okay, that's I pass to my friend.
Alright, thank you to Cik Muhammad Isham. Okay, my name is Muhammad Ashraf. I will explain about constraint optimization. The SUMT technique obtain an equivalent unbound trouble by way penalizing the unique characteristic for any constraint violation. This equivalent unconstrained problem then solve the usage of any unconstrained algorithm already discussed. The former is referred to as sequential unconstrained minimization technique, that's called SUMT method. A complete evaluate of this method is given in Fiacco and McCormick 1968 and later as direct or restraint strategy. This one is penalized goal characteristic is obtained from formula. We can see the Fx plus pi p over x, in which Fp refer back to penalized goal characteristic, Rp to the penalty parameter, and P function of x to the penalty of feature. Once and unconstrained most reliable solution has been found. The fee of penalty parameter is expanded and cycle of conventional optimization is repeated. The result is slow progress toward a constraint superior. The technique is terminated, which the objective characteristic converges among consecutive and constraint optimization cycle. One famous feature is outer quadratic penalty function, described as function max and plus the k equal to 1. HK function of x power of 2. Method as SUMT have become less famous as direct or limited method have ended up more matured and green. The penalty parameter has vast impact at the performance of the set of ruler, but its hashless based on a regularly must be set extremely big accurate quality outcome. Direct method at once clear up the non-linear restraint optimization as set of equation 1 at the upstairs. The remaining distinct restraint optimization algorithm to be had. The MMFD and SQP algorithm are among collection of gradient-based totally algorithm developed with the Sinim and co people. The method could be very touchy to shift the bound and might usually find the feasible answer. The direct technique that may be a counter, however, will no longer be discussed here. Encompass gradient projection and generalized gradient decrease method. Okay, that's all for my explanation. I will pass for my friend Muhammad Shafiq. Muhammad Shafiq, please unmute.
Okay, sorry. Okay, Assalamualaikum, good evening. All right, then we see the statement of problem. All right, we want to design of kendring. The equation to need to minimize is f function of x1 and x2 is equal to 2 bracket pi x1 x2 plus pi x2 squared over 4 and close bracket. And then it's subject to h1 function of h1 x1 x2 equal to pi x1 square times x2 over 4 minus 250 equal to 0. And second constraint is g1 function of x1 and x2 is equal to 2x1 minus x2 less than or equal to 20. And then the range for x1 is more than or equal to 5 and less than or equal than to 8. For the x2, the range for x2 is more or and less more and equal to 4 and less than and equal to 20. The figure 1.0, as we see, the d and the height. D is for the diameter, h for the height of the can. Okay, the statement of problem is the problem statement of problem is to design a kendring of suitable height and diameter. The simple method to solve the above linear programming is given below. Based on a idea, the application of quick simplet method on the dual simplet method or a new approach and estimate on the average number of steps of the simplet method of linear programming. Okay, we see one by one of the statement of problem. First, if the objective function of a given problem is minimization form, convert it to maximization problem. Later, we introduce the slack variable to form the basis vector and construct the usual simplex table. Okay, then we set xb1 or equal to initial basis solution. Then fourth step, we compute zgj minus cj less than 0. Okay, so we set the argument, if Zj minus Cj is equal to 0 for all j or optimality condition, and xbi is more than 0 for all feasibility condition, both exist, then the corresponding solution is the optimal basic feasible solution. Another argument is if at least one Zj is minus Cj less than 0, the dual simplex method is not applicable. And if Zj is minus Cj more than 0 for all j and at least one random variable of xbi less than 0 exists, go to step 5 back. Okay, the step 5 is dual simplex method is the mirror image of the simplex method. Okay, the first we have to check which one is the departing vector. Vector which has to move from the basic, select the most negative value of the xbi dot xbr is equal to minimum, where xbi is less than 0 or to departing vector. Check YRJ row value for all j. Then the argument is if YRJ is more than 0 for all j, no feasible solution exists. Then set another argument if YRJ is less than 0 for at least one j, the solution is that Zk in bracket Zk minus Ck over YRK is equal maximum, where in the open bracket Zj minus Cj over Yrj, where the Yrj is less than 0. This is a corresponding vector of Ak enter into the basis. Okay, problem formulation. We say the area of surface is A is equal to pi dh plus pi d squared over 2. The goal of this example is to minimize the overall cost of producing the redesigned solar can. The fabrication cost is related to the surface area, which is given by a function of x1, x2 is equal to bracket open bracket pi x1 times x2 plus pi x1 square over 4. Okay. Problem formulation. The constraint function is defined in terms of design variable. We see the contrast to the obesity issue. Consumer research suggests that people should only consume up to 250 millimeter of drink each serving. Studies have shown that the diameter of around 5 and 8 is necessary for comfortable holding. The height must be at least twice as tall as the diameter for aesthetic reason. So we can conclude that as below range, as we see 5 S1 is more or less than 5 and it equal or less than 8. While the X2 is more than or equal to X1. So the V is 250 volume. Okay. Later, my friend.
Okay. Thank you, Shafiq. My name is Muhammad Firdaus bin Abdul Aziz. I will continue the slide and until the end of the slide presentation. So from the problem and the formulation given by Shafiq, we conclude as the result as shown in the graphical plot as we present in the slide. So next, for the optimal solution we found, we can see our solution is feasible at the required values. And our minimized solution is F S1, S2 equals to 8.635 means when we choose our parameter as above, our cost will be minimized. So as per conclusion, we found that the linear optimization is a method which the solution for the problems could be found out. In this particular assignment, we also find that the optimization for the design of a soda can ring was done so that the cost of the can ring could be reduced. The design variables were height and the diameter. Quadratic programming was used to find the solution, and it was found that the problem was unbounded, and the value of height and diameter has to be 1.5 and 0.5 to given minimized cost of 8.635. Means that these values of the cost will be minimized. So that's all from me, from our groups.
All right.
To
Thank you for all. All right. Thank you.